Alrighty, here we go. Section 3. Make sure your notes reflect that, and the topic today is adding or subtracting rational numbers. Here we go. Rational numbers, remember, means any number that can be written as a fraction. And then what happens is anytime you write a number as a fraction, you can also write it as a decimal. Okay, so here we go. A lot of this is going to be a little stroll down memory lane to see if you remember this, okay? All right, so here we go. I can add and subtract decimals and rational numbers. Really, that should just say rational numbers with like denominators, okay? So decimals, yep. And then if you have fractions, then when you have a common denominator, okay? So let's start with the decimal part, all right? The big thing here for you to remember, and I think it reflects this exactly in your notes, line up the decimal point. So if I have 0.3 or 3/10, and then I have -1 and 2/10, and I want to add these together, the first thing I need you to think of is, oofta, who's winning this battle? What's the sign of my answer? They're different, okay? They're different. Which one is bigger? This guy is bigger. That's the sign that's going to win, okay? Now, once you've determined, I know my answer is negative, because they were different, you need to find the difference of these two numbers. Put the bigger one on top, smaller one on bottom, and subtract. 9/10. And it's negative, okay? It's negative. Look at the next one here. 12 and 5/10 plus -34 and 8/10. Before you even do math, okay? Before you even do math, I want you to kind of think about this. If it's hard for you when you have all this decimal issue stuff, round it. Think this is about 13. This is about -35. Who's winning this battle? Oh, the negatives are. So I know my answer is negative. I have to come off to the side now and find the difference between these two numbers. So now I don't have to worry about the sign. Sorry, the decimal point goes here. 34 and 8/10, 12 and 5/10. So I lined up my decimals, but because this was positive and this was negative, I have to find the difference because the signs were different. 3/10, 2 in the ones place, 2 in the tens place, 22 and 3/10. Ta-da! But it's negative. Okay, just like when I was looking at these, positive 13, negative 35, it's about negative 22. Yupper, yupper, yupper. All right, let's look at these ones. We got a couple more here. -1 and 2/10 plus 8 and 4/10. Aha, on this one, the positives are going to overpower here. There's way more. If it doesn't make sense, this is about -1, this is about +8. That should be an answer somewhere in 7 land, okay? +7. When I come over here to do the actual specific math, line up the decimal points, find the difference because one was positive, one was negative. 4 minus 2 is 2 in the tens place. 8 minus 1 is 7 in the ones place. Positive 7 and 2/10. Boom. That's close to my estimate. My answer made sense. What if you have a variable in there and then I'm asking you to evaluate and substitute a value for the variable? Go ahead. 62 and 1/10 plus whatever x is. This case, x happens to be a negative 127. Okay, simmer down. If the decimal freaks you out, think of it this way. This is about equal to 62, and it's like adding negative 127. Who's winning this battle? Oh, definitely the negatives are. They have way more people on their army. So now I have to do the actual math. My signs were different, so I need to find the difference and put this number on the top, the larger one, the larger absolute value in a sense. This is 127 away from 0. This is 62.1 away from 0. All right, different signs means find the difference. Oh, fiddlesticks, you have to borrow. Whatever. suck it up and just do it. 6 minus 2 is 4. I didn't have to borrow here. So I get negative 64 and 9/10. Boom. There you go. That's what happens. Next. Now we're getting into fractions, okay? So on this part in your notes, I think the pre-printed notes actually said positive 1/5, and I want you to change it. Add this negative sign in there. Okie dokie. Let's just dive in. None of this mamby-pamby stuff for us. Here's the deal with fractions. As long as you have the same denominator, here's where you end up, okay, with the same denominator. We don't add them. Remember that this fraction is like saying pieces of pizza, okay? So in this case, here's what's happening. I have 2/5 or 2 slices, and what I want to do, this negative one is kind of like taking one of those away from here, okay? Basically, look at what's happening in the numerator. This is like saying I have -1, and then I'm going to add 2 all upstairs in the numerator. Oh, well, -1 plus 2, that's just +1. That's in simplest form. Done. Easy. Okay, look at these. Ninths, I end up with ninths. What you need to do now is focus on the numerators. This is like saying -2 minus 5 more. If you can do this without thinking of it as an addition problem, go ahead. Otherwise, think of this as -2. Subtraction means add the opposite. -5 is like adding -5. That negative sign is just stuck to 5, whether I'm thinking -5 or plus -5. This gives me a value of -7. So you can just write it up there in the numerator, -7/9. Or you can put the negative sign out front and say -7/9 that way. Frankly, it's even okay or equivalent to put the negative sign in the denominator, although we usually don't do that. Usually you'll see it out front like this one. All righty. Okay, a couple more. 6/7 plus -3/7. And I think I probably even put that in parentheses. 7ths and 7ths give you more 7ths. You have 6 pieces and you're adding -3 or taking 3 away. You just end up with 3/7. That's it. Here, I'm in 4ths, okay? But what I'm doing is I'm taking 3 and subtracting -5 in the numerator. Subtracting a negative is like, let me boost this up a little bit, adding the opposite. That's +5. Minus a negative means plus. You get 8/4. Whoa. Slow down. Can't leave your answer that way. 8 divided by 4, that's exactly 2. 2 wholes, or 2/1, but you should write it like that. Okay? Sweet. Okay, what if it's an algebraic expression? No problem. What if I have a mixed number? No problem. First of all, simply plug this in. 7/10 plus m, but m is 3 1/10. Now, I don't know about you, but I'll be honest, okay? I'm old. I was taught to always add stuff like this vertically, not horizontally. So I kind of have to write it this way because I know I add the fractions first, okay? Just like when we were doing the decimals, you start on this far end and then work your way to the left. So do the fractions first. There really is no whole number here. If it helps you to draw in a 0 there so you line things up and organize it in a better manner, go ahead. But you get 3 8/10. That's not in simplest form. 8 and 10 both share a common factor of 2, 3 4/5. I think we have one last one here. 5/8 plus m. And I'm asking you, let 5 7/8 stand for m. Okay. Hey, I've got to do this vertically because that's just kind of how I roll. Okay. 5 7/8 and 5/8. I guess I put the 5 7/8 on top, but that's okay. Line up your fractions, line up your whole numbers. There doesn't have to happen to be a whole number here, so think of it as 0 if you like. 8ths and 8ths give me 8ths. 7 and 5 are 12. 5 and 12/8. Psst, newsflash, don't leave your answer like this. First of all, 12/8 is an improper fraction, so don't do that, okay? I still have a 5, but the 12/8, 8 can fit into 12 once, and then I'd have 4 left over. So really, this is 6 and 4/8 instead of 5 and 12/8, 6 and 4/8. But 4/8 is not in simplest form. Get that sucker in simplest form. 6 1/2. There you go. That's all kind of review. Let's take a look at one where it's in some context of a real life situation or a word problem. It says Sarah's broad jump is 1.6 meters. Okay, remember broad jumps where you're standing still and you're just kind of swinging your arms and boom, there you go. Jill's best jump is 1.47 meters. How much farther can Sarah jump than Jill? How much farther implies subtraction. Okay, so we have to take Sarah's value and subtract Jill's. Now, I have to do things vertically, and since these are decimals, I'm going to line them up. 1.6, or 1 6/10, 1 47/100. Now, hold your horses. Just because there's nothing here, you can't just say nothing minus 7 gives you 7. No, it's really a 0, so fill in that spot. You have to borrow. Now subtract. I'm going to make sure my decimal points in my answer. Always start from the furthest to the right and work your way back left. That's a 3. This is now a 5. 1 minus 1 is 0. So pretty small amount, it looks like. But really, 13/100 meters is actually not as small as you think. Okay, hold on 1 second. I'm going to grab my meter stick. You know, America's kind of dumb because we never switched to the metric system in the 70s when we were trying to. All right, so 13/100 of a meter. Well, here's an entire meter stick, okay? It's a little longer than our yard. 13/100 meters is really the same as 13 centimeters, which is actually from the tip here to, here's 13. So it's about this long. It's around 5 inches, actually. So in the context of a broad jump, that's kind of a substantial distance. When we say 13/100 of a meter, in some ways that doesn't sound like it's a very substantial distance, but think of the unit that you're using. This is a pretty big unit. It ends up being about that much. And in a broad jump, that's kind of a lot. There you go. Watch your numbers. Watch out for negative signs. Think about what you're doing. If you have decimals, line up the decimal points. If you have fractions, make sure you have a common denominator and deal with the numerators. Okie dokie. All right. Good luck, and may the force be with you. Take a look at Schoology, or if you're in the classroom, look at the front of the board for what your assignment is. Good luck.